Okay, so now that we've defined domain, we've looked at the definitions of vertical and horizontal asymptotes and the kind of behaviors that we should expect from a graph that has them. How do we actually find these? So we're going to talk first about finding vertical asymptotes, and that's our first bit of business. How do we actually go about finding a vertical asymptote in a rational function? Well, by what we said before, x equals a is a 0, right? If x equals a is a 0 of q of x, the denominator of our function, and if p and q have no common factors, then x equals a will be a vertical asymptote of that function f of x. Now, does that mean anytime we're looking for a vertical asymptote, we set the denominator equal to 0? Well, first, we should look to see if there are any common factors. Like, let's take a look at our example number 1 right here. G of x is x cubed over x squared plus 1. There are no common factors, so we don't have to worry about that part yet. Since there are no common factors, what we need to do is we need to look to see if there are any zeros of the denominator. So, to try and find the vertical asymptote, we're going to set x squared plus 1 equals 0. Let's see what's going to happen. Well, if x squared plus 1 is equal to 0, that means x squared is equal to negative 1. And x squared equals negative 1 is going to have zeros at x equals plus or minus the square root of negative 1. That is to say, x equals plus or minus I. So now you look at that and you go, well, what does that mean? What it means is that there are no real numbers that would give us a 0 in that denominator. Therefore, we can conclude that there are no vertical asymptotes. It's not a guarantee that we always get one. All right. So when you're looking for a vertical asymptote, first of all, we have to make sure that the denominator actually gives us a real solution. Only real solutions of the denominator's polynomial will give us those 0. So let's try f of x right here in example number 2. Where are the vertical asymptotes here? Well, again, there are no common factors in the numerator and denominator. And yes, I know that x looks really, really tempting, but remember, you can only cancel common factors, not common terms. The numerator is already in factored form. The denominator is not, right? Our denominator, x squared minus x minus 6, turns out to be directly factorable. Again, if you need to see how factorization works, please go back to some of my other videos. But in this case, it looks as though we're going to factor. We need two factors of negative 6, whose sum is negative 1. That turns out to be negative 3 and positive 2. And so we end up with x minus 3 equals 0 at x equals 3. And x plus 2 is equal to 0 at x equals negative 2. So our vertical asymptotes are those vertical lines. And every time we write a vertical asymptote, write it as the equation of a vertical line. X equals the number, not just the number. It's not a coordinate point. It is a vertical line. X equals negative 2. X equals 3 would have to be my answer. Well, how about number 3? Now it looks like we got a little bit more complicated stuff going on. So what we really need to do before we look for any vertical asymptotes and see if there's going to be any common factors in the numerator denominator. And I'll note that h of x is factorable in the numerator as well as the denominator. In my numerator, of course, x squared minus 9, I know that to be x minus 3 times x plus 3. In my denominator, I'm going to have to look for two factors whose product is equal to x squared minus 2x minus 15. And I know both binomials start with x to give us x squared, but what gives us negative 15 as a product whose sum is negative 2? Yeah, you got it. Negative 5 and positive 3. And now we know, look, there's a common factor. So we'd have to reduce that, and we should write that h of x is actually the function x minus 3 divided by x minus 5, provided that x is not equal to negative 3. X equals negative 3 is still out of the domain, right? It's only what the original function does. But the only number that's going to make a difference for us for our vertical asymptote is going to be where the denominator of the reduced polynomial x minus 5 is equal to 0. That is going to be at x equals 5. So our vertical asymptote is the line x equals 5. That's it. That's the only ones that we can find right here. Okay, so vertical asymptotes, number one, make sure you've got no common factors. Once you've found that, then look for your zeros of your denominator. The line x equals whatever that number is will be your vertical asymptote. Okay, one more video in this group.